Hey guys, welcome to another online lesson offered by NP Tutoring. In today's lesson, we're going to look at this difficult trigonometry question that involves differentiation. So let's get on with it. So this question wants us to use calculus to find the coordinates of the stationary point, and they have given us an equation and its domain. The domain is very crucial for a trig function because trig functions are continuously repeating. Now, it may look scary at first, but we can break it down and make it easy. So, we know to find the stationary point, as said here, we need to find the derivative, because the derivative is the gradient function. And at the points when the gradient function is equal to 0, these are called stationary points. So when the dy dx equals 0, this equals a stationary point. So to find the stationary point, we need to differentiate this expression. It's very simple. So the way we will go about doing that is that dy dx is equal to, and this is a function given like this, and we can use the product rule. The product rule says to differentiate the first part of the function, so x, and multiply by the second part. Do plus, you differentiate the second part and times it by the first part. And so let's get on with it. So we differentiate the x, we get 1 times sine x, as I said. Then we do plus, and we differentiate the second component, the sine x. And now, to differentiate sine x, you want to remember that sine differentiated becomes cos x, and then you want to multiply it by the first part, which is x. Now, an easy way to remember differentiating trig functions is this. Just remember that sine differentiated goes to cos. Cos differentiated goes to negative sine. Negative sine differentiated goes to negative cos, and negative cos differentiated goes back to sine, and the cycle repeats, and the cycle then continues. So that's an easy way to remember it. I'll move this out of the way now. Cool. Right, next step. Now, to find the stationary point, we want the derivative function, which is this, to equal to 0. So let's do that. So then 0 will equal to sine x plus cos x multiplied by x. Now, what we can do using our basic algebra knowledge is move this over to this side. So then it becomes negative sine x is equal to cos x times x, and now we can divide by cos x on both sides. So we get, let's do that in green actually, cos x, move that over and divide it. So we get negative sine x on cos x is equal to x. Now what we want to observe is that that sine x on cos x can actually be an expanded version of tan x. So this just becomes negative tan x is equal to x. Now, if we solve this in our class pad in the domain 0 x 2 pi, we get the following solutions. We get x equals 0, x equals 2.0288, and we get x equals 4.9132. Now, if you have the standard mode on your class pad, you'll get an answer in terms of pi. I didn't have that. Now what we want to do is that we have all the stationary points, and we want to verify it. And a part of the question was to identify the nature of the stationary points. Now the way we do this is by finding the second derivative. Yes, the second derivative. So y double dash of x is equal to, and now we just want to differentiate Now we just want to differentiate this expression. So to do that, let's just copy it over. Let's not copy it over. So then is equal to sine plus cos x times x. So now let's differentiate this. We will get, so as I said before, if you differentiate sine, you get cos. So then this will become cos x plus, and then we want to differentiate this, but this in itself is a form of the product rule, so we want to do this separately. So the way we'll do it is we'll differentiate the cos, which is, as I said before, negative sine. So we get what? Negative sine x times x plus differentiate the x, so which is 1, and then you times it by the cos. Okay, so now we have this. Now straight away we can see that we can cancel out the causes. So yeah, we can cancel that out. So the second derivative is just equal to 1 plus 1 minus sine x times x. Yeah, and now what we want to do is we want to input all of these x values, this one, and this one, into the second derivative. This will give us the nature, and if the second derivative is greater than 0, this means that it's a minimum point. And if the second derivative is less than 0, this means it's a maximum point. So we want to sub all of these in. To save time, I've subbed them in, and 0 and 4.9 turned out to be minimum points because the second derivative was greater than 0, and 2.0288 was a maximum point because it was less than 0. Next, once we have these, now what we want to do is we want to sub in these same x values back into the original function, which is this. This will give us the y part of their coordinate. So if we sub those in, we get 0, 0 as being a local min, and we get 4.9, and this gives us a y value of negative 4.8145. This is a local minimum, and we have 2.028. This is 1.82, and this gives us a local maximum. So in this question, we have successfully used calculus to find the coordinates of the stationary points, and we've identified their nature as being minimums and maximums. Thank you for watching this lesson. If you want more help that's geared specifically towards your needs, please check out the description box and book your first session today with our NP tutoring service. You get your first hour free and a whole bunch of ATAR resources that add up for free. Thank you.